Good morning, dear students. We have already discussed about the fringe pattern which is captured in Young's double slit experiments in the previous video, whether the light sources are coherent or incoherent sources. Coherent sources means bright and dark fringes are created, and if it is non-coherent sources means fringes are not created. That is what we have discussed in the last video. And now we are going to discuss about calculation of path difference. Path difference we have already discussed in the last video itself. S1p, S2p minus S1p is the path difference, but we have already studied. If you have doubts, just refer the previous video. Okay. And now if we see, we will always consider two sources S1 and S2, and we will consider a point at a particular distance. That point is taken as P. As you can see here, this is the referral diagram. This is S1 source, S2 source, and this is the point P. Like this, here also, we are creating a coherent sources by using a single light source. One single light source is used, and it is the light rays are passed through a single slit, and wavefronts are created like this. And after that, there is a two slit which is kept at a particular distance D, and these two slits acts as a secondary light sources. So it will be a light sources. According to Huygens principle, each point of the secondary wavefront will behave like a secondary sources, right? Secondary wavefront. Similarly, here S1, S2 also will behave like a secondary sources. So the same thing is explained in this diagram. Can you see this diagram? This diagram, S1 and S2 is considered as the slit, and you can consider this as a source of light also. S1 and S2 is the source of light, where the light ray goes and interferes at a particular point like this. S1 and S2, the waves are created and interfering at a particular point. We will be taking a point P at a particular distance. Okay. So from this source, the distance of point P is, the distance is D, capital D. Okay. So this is a point B, point P, S1, S2. The difference between S1 and S2, distance between S1 and S2 is small d. And this distance, you can consider this as a screen where the bright and dark fringes are created. This is screen, and the same thing is represented in the diagram also. If you consider this as a screen, distance between the screen and the source is capital D. Okay. So by using this diagram only, we are going to find it out the path source, path length. Okay. And one more important thing which we would like to see is this one. So as you can see here, the light sources, what is the from this experiment, what is the conclusion we come to? That is important result drawn from this above experiment is bands were formed as a result of interference, and interference was due to the overlapping either constructive or destructive of waves. This is a constructive and destructive of waves. Constructive wave means bright fringes are created, and destructive means dark fringes are created. That is what we have already discussed, right? So constructive and destructive overlapping depends on the path difference. So this depends on the path difference only, right? So if the path difference is integral multiple of lambda, that path difference is integral multiple of lambda means that will be constructive interference. If the path difference is non-integral multiple of lambda means this will be destructive interference. So it depends upon the path difference. Everything depends upon the path difference. So path difference is very important to find out whether the fringes are dark fringes or bright fringes, whether it is constructive overlap, constructive interference or destructive interference. That is why we are finding the path difference in this by using this diagram. Okay, what is the path difference? S1p, S2p that we have already discussed. Similar thing that we are going to find it out, the path difference. So for that we are taking this diagram, S1, source 1 and source 2 with the distance of small d. And there is a screen which is kept over here. We will take one point P at a particular distance. Okay, the screen is kept at distance of capital D from the sources. Okay, the distance from the point and the origin O is X. Okay, this is x that we are considering, this is d. Okay, similar thing, the same diagram can be taken like this also. That is a small changes that for your understanding. Okay, this d can be bifurcated into d by 2 and d by 2. That is distance between O and S1 is d by 2. O and S2 is also d by 2. We are bifurcating this by 2. So if you draw a straight line to the screen, it will be touching here as a right angle triangle. That is 90 degree. It makes an angle over here. And from here also, if you draw a straight line, it will also touch the screen with the 90 degree angle. So these two is considered as a right angle triangle. Okay, so we already know that distance from this O to P is x. So what we are doing, this is considered as a triangle. This is x minus d by 2. This because this distances should be minused. Okay, that from O, this distance should be minus from x. So that is why this d by 2 is minus from this total x. We are writing this as x minus d by 2. Understand this diagram clearly, then only you will understand the derivations properly. Okay, that is very important. And from the origin down, if you take it out, the second half of d by 2 is added, because from the point to O, the distance is x. This distance should be added. So what is this distance? This is similar to that of a distance here, d by 2. So we are adding x plus d by 2. Here we are reducing this distance, x minus d by 2. Here we are adding the distance, x plus d by 2, to calculate the right angle triangle value. Okay, I hope you understand this diagram. By using this diagram only, we are creating this diagram also. Okay, this is the small change that we are making to find it out the path difference. So what is the path difference? Path difference is, we have already discussed that S2P minus S1P is the path difference. S2P minus S1P is the path difference, which we have already discussed in the light sources, secondary light sources of Young's double slit experiment. So here, by using Pythagoras theorem, this right angle triangle, and second one, this right angle triangle, for these two right angle triangles, we are using the Pythagoras theorem. For Pythagoras theorem, we already know that hypotenuse squared is equal to square of the other two sides. What is hypotenuse squared here? First triangle, S1P is the hypotenuse. So S1P squared that we are taking it here, hypotenuse square, is equal to square of the other two sides. What is square of the other two sides? We know that the source is kept capital D distance from the screen. So this distance is considered as D. So this D value that we can consider for this value, other two sides. Okay, one, that is D squared, plus what is the distance between P and the right angle point which is touching in the screen? That is x minus d by 2, which we already know that. So we are taking this other value as x minus d by 2, the whole square. So hypotenuse squared, S1P squared, is equal to square of the other two sides. One side is d squared plus other side is x minus d by 2, the whole square. This is equation 1 that we are considering over here. Then the other triangle that we can consider over here, what is this? S2P is the hypotenuse. S2P squared is equal to square of the other two sides. What is the other two side? One side is capital D squared, plus other side, this is the distance. This x plus d by 2, the whole square. So hypotenuse squared, S2P squared, is equal to d squared plus x plus d by 2, the whole square. This we are taking this as equation number 2. So we already know that to find it out the path difference, S2P minus S1P. What is the S2P value? S2P squared minus S1P squared. S2P value, we are writing it here, d squared plus x plus d by 2, the whole square, minus d squared, S1P value, d squared plus x minus d by 2, the whole square. So what will happen? This minus d squared and plus d squared will get cancelled. Okay. So if these two getting cancelled means, what is this in this form? A plus b the whole square form it is there. So if it is a plus b the whole square form, we can explain it by a square plus b square plus 2ab. What is this? A square is x square, b squared is d by 2 the whole square. It will become d squared by 4 plus 2ab, 2 into x into d by 2, right? 2ab. So this 2 and 2 will get cancelled. Here, minus, this will be in the form of a minus b the whole square. A minus b the whole square is equal to a squared minus b squared plus 2ab. So here a squared, sorry, a squared plus b squared minus 2ab. When this minus will be multiplied inside, it will become minus x squared minus d squared by 4 plus 2x d by 2. 2 will get cancelled. So here plus x squared and this minus x squared will get cancelled. Here d squared by 4 and d squared by 4 is also will get cancelled. Here what is the leftover? 1xt, here 1xt. So what is the total? 2xt is the path difference that we found it out. So s2p squared minus s1p squared is equal to xt plus xt, 2xt is the value. Okay, here now it is a squared minus b squared format that you can see here. Can we abbreviate it? What is a squared plus a squared minus b squared formula? It is a plus b into a minus b. So we are writing this as s2p minus s1p into s2p plus s1p. A minus b, a plus b that we are writing it over here is equal to 2xt. And we are keeping the s2p minus s1p here, path difference, because it is a square value, we want to remove the square. So what will happen? We will keep the s2p minus s1p value is equal to 2xt by this total value of s2p plus s1p will come down. Here you should understand that this d, what is meant by d? This d is very, very small. For example, you can do this experiment in your home itself. Take one candle, light it. In front of a candle, if you take a white paper, by keeping a small pinhole with a very small distance of 2 millimeter or something, that is 2 millimeter is sufficient. 2 millimeter or yeah, 2 millimeter. If you put a hole in that, if you put the light to pass through the 2 points, if you keep a screen in front of the 2 slits, there will be a bright and dark fringes may be created. So that the distance between the 2 holes will be 2 millimeters. So you can consider this S1 and S2. The distance between S1 and S2 D is very, very small, that you can consider this as a 2 millimeter distance. For example, I'm telling this to you. And if you keep a screen around 5 to 6 centimeter distance means this small d distance between the source 1 and source 2 or slit 1 and slit 2 will be very, very less compared to the distance from screen to the source. So d will be very, very less than capital D, and x will be very, very less than capital D. This x means the slit, that fringes which is created. That x is also very, very less. The less value as capital D means you can consider, you can neglect this value as 2D. Why this is considered as 2D means, if 2 millimeter difference, there is 2 light sources that we can consider. The screen is kept at a particular distance D means from S1 also 1D, from S2 also 1D. So it can be considered as 2D is the difference over here, that we can consider this value as 2D. S1P 1D, S2P 1D. So that D plus D 2D is the value that you can consider over here. So S2P minus S1P is equal to 2xt divided by, instead of S2P plus S1P, we are substituting the value which we are taking this as assumption, 2 capital D. So what will happen over here? This 2 will get cancelled. So x small d divided by capital D is the path difference that you can consider for the fringes to be created. So the path difference which is created is x small d divided by capital D. Whether it is a constructive interference or destructive interference, that we can substitute the value and we can find it out whether it is constructive or destructive. But still, to find the path difference, this is the way of finding it xt by d. Okay, I hope you understand. And this calculation of path difference, how that we are considering S1 and S2, and what is the path difference which is taken over here, what is the derivation which you are seeing in this page, it is already explained in the form of in the handwritten form. Okay, I hope you understand this handwritten form. And for your additional information, I am giving this printed form also. Go through this and you'll have a clear idea about this. So that the path difference is x small d divided by capital D. Okay, so what is the observation that you understand from this diagram? That is, light from coherent sources produces alternate dark and bright bands on the screen, placed some distance away from it. So this is what we understand from this young double slit experiment. Okay, go through this video once again so you'll have a better idea comparatively. Okay, the rest of the thing we'll see it in the next video. Thank you.